So you might wonder, why did you skip all those pages? Some of the questions, if you go back, will need this skill. Okay, so I'm just going to show you real quick. I'm supposed to do this? Okay. I don't know, right now it's not the right moment. There has to be the right time for that. Yeah. Go ahead. I thought you were going to volunteer. No? Okay. Calculating the height of a triangle. Okay, so that's today's lesson. Did I tell you that sine law and cosine law, you don't know cosine law just yet, but it works for any triangle. Right triangle, oblique triangle, it doesn't matter. If it has three sides, sine law, cosine law work for you. I just tell you this, sine law has a bit of a problem. Sine law, you will not see that problem. I will make sure you won't see it, but at some point towards the end of this unit, I'll reveal the problem that sine law has. Sine law has a bit of a problem, so we need to account for that. But until then, you don't have to worry about anything. If you have a few highlighters, colors are going to come in handy here. Should have warned you about that. So page 17, I'm just going to quickly go to it. Sometimes when we're trying to find the area of a triangle, we need the height. If you want to know how high above the ground is there a certain item that is being looked at, you need the height, right? Sometimes it's an imaginary dashed line, and sometimes it is actually part of a triangle. Okay, this could be like an actual cliff, right? But let's say there's a kite up here and there's two people looking at it, or a plane is up there and there's two people looking at it. You want to know how high above the ground is that. So that's what we're going to try to find today. And I'm sure you're not going to find that too, it's not going to be mind-blowing. You're going to be like, yeah, I saw that coming, right? So that's the color that I'm going to use for the height. And we're going to give this several approaches. This triangle has too much information, TMI, okay? To be honest, it has a lot of information. You won't always have this much information given. So you will either have this slant, most likely, or you will have this slant given. I call that the slant. Right? And so we're going to find the height here. This is triangle 1. This is triangle 2. So basically the height always makes a 90 with the ground. That's a prerequisite, correct? You always, when you want to measure the height of something, you always make it a 90 with the ground. That creates two smaller triangles. I will just show you that the height will be the same whether you use this side or that side of this big oblique triangle. Okay, so if we deal with this first one, let's copy that out. Let's cut it out. Okay, you have a 90 there. This is triangle number 1. We highlight the height. We highlight the diagonal. This is 4.52. This is height. Does the 8.52 come with me to the small one? No. It goes from end to end, right? Can I split that in half and then make that work? No. Are there instances where you can split this in half and then take it with you? When it's an isosceles triangle or an equilateral triangle, you could do that. But most of the time, I would say 99% of the time, you will not be able to do that. So please don't fall for that. So I have this. That's the one I want to find. So, and I know this angle right here. This is 59.8 degrees. Okay, so how would I find the height there? Using a sine law. Do you have a pair in this triangle? A known pair? Right? The 90 and that side. So sine law. So we're going to go sine of 90 over 4.52. And sine of 59.8 degrees is going to be across the height. That's the one I want to find out. And so let's do this. Height is, you go to the side where the variable is, you cross multiply, and then you divide. So we're going to go 4.52 times sine of 59.8 divided by sine of 90. Before we do this, find out what sine of 90 is, because you'll be somewhat surprised by that. Maybe not. Sine of 90 is 1. Sine of 90 is 1, okay? So what is going to happen if you go 4.52 times this divided by sine of 90? It's just divided by 1, so it's not really doing anything. So just so you know, when there's sine of 90, I ignore it. I don't even bother with it. So I just go 4.52 times 59.8. I get 3.91 feet. But let's highlight, like, how did I find the height? What did I multiply? I multiplied this slant, okay, times what? Times sine of that angle, right, that's touching it, 3.91, okay. Let's approach it from the other side, from this side. The height should be the same, correct? Yes? The height should be the same? Okay. This is a 90. By the way, when we do 90s, we don't bother putting a 90 on both sides of that. We just make one 90 and it's implied that the other one is 90 because it's a straight angle, right? Height, 7.1, 33.4 is given. Let's see if you can follow along. This is the slant, correct? I used orange for it because it's the other slant. If you could just look at the pattern, if you could look at the previous pattern, where we multiplied this slant times what? Times sine of that angle that's touching it. What would be the pattern on this side? What would we do to find the height? 7.1, right? Times sine of 33.4. That's the pattern. If you don't believe me, let's do the pair. Sine of 90 over 7.1, sine of 33.4 over h. H is 7.1 times sine of 33.4 divided by sine of 90. And we know sine of 90 is just 1. I'm going to highlight the 7.1 with the same color of the slant. And then just go 7.1 times sine of 33.4. And lo and behold, I get 3.91 feet. We're not surprised by that. We got the same answer no matter which one we used. You're not going to do this every time. You're going to just figure it out from using one of the slants if you have more than one. Okay? Okay. So here's this is from now on. If you're comfortable with this, this is how you find the height of a triangle. Can we under side length write down slant? And maybe if you copy this into your study sheet, maybe you just want to have the word slant in there. But it's slant, that's side length times sine of adjacent angle. And maybe in your study sheet you want to have just a little diagram of a triangle where H is labeled like this. And maybe just come up with a quick example. Like, let's say this is 10 inches and this is 30 degrees. Just make a triangle right next to this formula and then just quickly tell yourself H in this case is 10 times sine of 30. I think that's all you need. Okay? I'm going to attach it to that formula. Slant times sine of 30. Done. So I'm giving you 3 examples. These are all unique, guys. They're all unique. This one is the one we just talked about where something is above ground. What is this one? This one is a scenario where, let's say you're in the ocean and there's 2 ships and they're both looking at something underneath the water surface. Then the height of the triangle is for us the depth of the ocean, right? How deep the water is. It's just an upside down triangle. It still works. What about this one? Here the height is outside of the triangle. It still works. It still works every time. So I'm just going to use one color for my slant. Every single time I'm just going to give it one color. If you wanted the height of this, you would go PQ, side PQ, times sine of P. Oh, sorry, let me bring this up a little bit. Some of you back there are probably struggling with this. Okay. What about this one? I'm going to highlight a random diagonal. I'm going to go like this. Okay. If you knew that diagonal, to find the depth of this triangle would be EF or FE times sine of what? Can I use sine of D? If I'm using this slant, can I use this? No. What does adjacent mean? Adjacent means that angle has to like touch it right here. So it'd be sine of E. What about this one here? This slant times this angle right here. So H is QP or PQ times sine of P. And I'm going to give all of these a green one, a green highlight. Okay. So I'm going to say all the way to 21 is fair game here. So homework, page 18 to 21. If you're done 18 to 21, I'm going to say go back. Let me just see the pages here. Hold on, I'm coming back. Everything to 16, I would say, is fair game. But I'm going to chunk this up. 11, pages 11, 12, 11, 12, 14. These all have height in them to a certain, like at some point you're going to have to find the height of the triangle to do this properly, right? To answer the question. So that's your task. Okay, that's your task. Remember, I'm going to do the first one on 18 because every time students seem to have a difficult time with that one. Let's go to 18 where it says extras. And then I'll let you work. How's that? You get some class time, use it. Okay? Solve the following triangle. What does solving the triangle mean? All sides and angles. That's what that means. Look carefully. I added this over the last year? It's like, look carefully. What can you possibly pick up? Do you notice these markings here? This is an isosceles triangle. They will come up from time to time. Okay? How's that helpful to us? If these two sides are the same, what do we know about the angles across from them? There will be the same also. Okay? This one is different. 72 is the only one that's 72. We know that these ones are the same. So, this is angle X would be the same as angle Y, right? So let's solve for one of them. We don't care. Angle X would be what? 180 minus 72. And then we split whatever is left exactly in half. Okay? So what would that be? That is 108, 54. Angle X is 54 degrees, and we know that angle Y is also 54 degrees. So guess what? You've solved for all angles just like that, because it's an isosceles triangle. Please don't use sine law, don't try. Do you have a pair as is? Like, as they give you the question, do you have a pair? You don't. But you can easily find the other two angles because this is an isosceles triangle, only because of that. But I need your attention a little longer. What if 72 had been over here? If this is 72, and you've got this side being equal to that side, then we know that this is 72 also, correct? So then it's actually 72, 72. You need to find the one that remains, right? So you have to be careful. Which one are they giving me? Are they giving me the one that is different from the other ones? In which case I just subtract it from 180 divided by 2. Or are they giving me an isosceles triangle where one of the equal angles are given, right? One of the ones that is equal to the other is given. So then it's different, and it would be 180 minus 72 minus 72 to get the one remaining angle. So you have to be careful. So I've got the angles. All three angles are known. Now I could, this is 54, this is 54. Now you have a pair, correct? If this is 15.9, I also know that this is 15.9. So I really just have to solve for one more side, which is side Z. That's it. So isosceles triangles are a lot easier than all the other ones, in my opinion. Okay. Do you have a pair? Yeah. Which pair? This one or this one? Which one should we use? I'm just joking. It's the same, right? Stop. So sine of 72. By the way, if you missed this, if you missed that this is 15.9 and you're like, oh, this is my pair, and then I'm going to use this angle to solve for that one, guess what you would get if you calculated it? 15.9. So whether you catch it or not, you will find out that, oh, I did all that work for nothing, right? I did extra work without needing to. So Z is cross multiply. So please get really good at just solving these to, even if you think it's a little bit repetitive, do yourselves a favor and really practice this skill. 18.69 miles. Does it make sense that this one is longer than the other two? 72 is the largest angle, correct? I should have the longest side across from it. And it is the case, right? So it's kind of confirmation that things are going well. Okay. For all of the questions that follow, just so you know, it's asking you to determine the height as well every time. Determine the height as well. So this is what I'm going to do. If you have a highlighter, I'm just going to tell you, this triangle right here, once you solve for the missing side, like the missing side or angle, you want to proceed with finding the height as well after, okay? The second triangle here, you want to find the height inside that triangle. Okay? And I really want to make sure you understand. Could you find this height? Make sure you pay attention because this is going to save you a lot of time. Could you find this height with the information given as is? This is a slant, right? And you've got the angle that touches that slant. You could use it using that side and this angle for sure. You could also use it if you find this slant and that angle. You better get the same answer, right? You should get the same answer. So practice that, but first solve for what it's asking, right? Which side or angle, then worry about the height, okay? So keep doing that over and over. While you work, I will post the answer key, but I think some of you just like to know right off the bat, so I'll write down the first couple for you, okay? So just write this down. The height for this one is 464.40. The height for the second one is 10.84 centimeters. And the height for the third one is 20.30 centimeters. I should tell you that the last one, because it's a little crooked, right? This is the height we're talking about, which is basically more like a depth, right? So that's what I'm asking for there. But it's still considered the height of the triangle if this is your base. Okay. Do you remember how to find the area of a triangle? Base times height divided by 2. Right? Base times height divided by 2. If you, I feel like I should put this somewhere here. Area of a triangle is base times height divided by 2. You won't come across that now, but at some point. All right, I'll post the answer key. You work through the pages I've assigned. Yeah. You need the pages one more time? Here are the pages one more time. Down here. Okay?